We're going to start off with the quiz and work our way back into object-oriented programming. I think Mentimeter changed their counter for the number of people that they have in the bottom right. It's quite nice now. Okay, it seems like the two new students who are joining us might be a little bit late. Let me just see. Sorry about that. Ah, okay, cool. No, there's Taffy. Cool.
Yes, sir.
And Chico's here too, cool. I'll maybe add you guys to this class's register as well, so that I can mark that you're here.
Okay, sir.
Cool. So yeah, everyone just join the quiz, and we'll get started with, or at least remind ourselves, refresh our memory about what we learned last week. Maybe wait for another couple of seconds, and then I'll just start the quiz. Ooh, someone got the Swedish flag as their icon. The others I think we've seen before, maybe. But I don't recognize the magician's hat. Yeah, I'll wait about 30 more seconds. And yeah, the URL and the code are in the chats, but they're also at the top of the screen on the slide. Okay, cool, another person joined, that's great. Okay, let's get started. Remember that you can join in the middle of the quiz. There's nothing that stops that. You just get thrown in wherever we are. You have created a class and you don't want its functionality to be inherited into a base class. Which keyword can achieve this? Starting off with some interesting ones. So this one should hopefully remind us about something we learned about during the inheritance portion of the lecture. You have created a class and you don't want its functionality to be inherited into a base class. Ooh, you know, I suppose, that's interesting. I'll go through it when we start discussing it though. Let's see what people said. Interesting. So no one said sealed. Okay, so abstract means that you can only inherit from the class. While I was reading it, I was thinking like, I think a lot of people will say private, because private would stop specific functionality. Like if you mark something as private, it'll stop specific functionality, but it's not for inheritance specifically. Let me show you guys this just to remind you. So if you remember, so we discussed inheritance a little bit, and then there were these two words, abstract and sealed, all right? Abstract and sealed. So if we would have a class that it is inherited from, so our base class is polygon and our derived class is rectangle inheriting from polygon, okay? You can then also create objects of type polygon and objects of type rectangle. So hopefully we're okay with that kind of structure. If we apply the word abstract to the class polygon, that means we can still inherit, but we will not be able to create objects of type polygon. So that's all abstract does. If we apply the word sealed to polygon, then we would not be able to create a derived class that inherits from polygon, which effectively makes that impossible. Okay. So hopefully that refreshes your memory a little bit. I suppose putting the word private there is, it is something the MTA would do though. So you must just be sensitive to the fact that it said inheritance. So we needed to be thinking about the concepts of inheritance, which should necessarily evoke these ideas of abstract and sealed when applied to the inheritance of a class. Okay. So yeah, but yeah, interesting one. Let's see how the rest go. On to the next question. Which keyword refers to the current instance of a class? The current instance of a class. Which keyword refers to the current instance of a class? So I have told you this, but yeah, the wording might make it a little bit freaky. But let's see what people say. Because I don't think you've seen it worded in this way before. Okay. A fair sort of distribution of answers. Interesting. So method is not actually a keyword inside C#, eh? Method is not a keyword inside C#. We have methods. There are things we call methods, but method itself is not taken. Static, if we mark a method as static or a property as static, that means that, or rather just a method. If we mark a method as static, like public, static, void, whatever, that means that you don't need an object to use it. Okay. So in fact, so yeah, this is the answer because we can say this dot height, for example, and that refers to the height of the object that we are using, the instance of the class that we are using. If you label something as static, that means you cannot use this keyword when working with it, because static means that you don't need an object, and this refers to the object. Okay. Hopefully that makes sense. Maybe we'll see a little bit more of this today. I'll include it in our lecture content today. You have created a method whose functionality must be available only inside its class and in any derived classes. Okay, so be careful. Must be available inside the class and in any derived class. Which keyword specifies this? Okay, hopefully this one. Okay, let's see how that goes. It looks like another person joined the quiz since we started. That's cool. Hey, okay. Majority rules. Cool. So yes, that is correct. Democracy worked in this case. So public means that it's accessible anywhere. Private means that it's accessible only inside the class. Protected means that it's accessible inside the class and in any derived classes. Internal means that it's accessible in the project or in the assembly. And we briefly explained what that sort of means. But yeah, so protected is what we were looking for here, because that means it'll be available inside the class and in anything that inherits from our class. Okay. Nicely done. Nicely done, guys. You need to create classes in a C# application, but must be able to control the access rights to both functionality and data. Which OOP concept can aid in this? So we want to be able to control the access rights. So which object-oriented programming concept does that refer to out of the 4 that we have here? Cool, nice, nicely done again. Okay, let's go through what these are. So inheritance, that's the ability for a base class to, or for a derived class to inherit functionality or to derive functionality from a base class. So the ability for a base class to share its functionality with many derived classes, okay? Encapsulation, which is the correct answer here. Encapsulation, even the English word, right? It's to encapsulate, protect, protection. So this is what access rights refer to, right? Security. We want to wrap our classes, you know, keep them safe, keep the data safe, keep the functionality safe. Polymorphism is, so we have inheritance, which allows a base class to provide functionality to a number of derived classes. Polymorphism extends that by saying, yeah, a base class can give functionality to numerous derived classes, but each of those derived classes can have their own form for whatever they are inheriting. So the inherited functionality can have many different forms in the different derived classes. And how do we remember that? Polymorphism, that's Greek. Poly means many, morphism means forms. Okay, so many forms. It can take on many different forms in the derived classes. Abstraction, we haven't actually covered yet. We're going to cover that in the first bit of today's lecture. Okay, but yeah, that's the last OOP concept that we have to cover, and it's super easy. Shouldn't take us too long to get through. If you understood polymorphism, then abstraction should come quite easily. Okay. You want to replace the behavior of a virtual method in a derived class, even when the variable references the base class. How can this be done? So you want to replace the behavior of a virtual method. So we have a virtual method inside we declared it as virtual inside the base class, and we want to replace its functionality in the derived class. But the new functionality must take effect even when the variable that our object references the base class. Okay, so just wording it slightly differently maybe for some assistance. I know these are quite tough. I did mention chapter 2 is quite hectic.
Okay. Same, like that.
Yo, okay, everyone got it. That's very cool, guys. Nicely done. Or most people. One person said new.
Okay.
I'm glad. I mean, so new and override were the two options, right? So abstract. Oh,
But I was in the past, man. I was in the past.
Your mic is.
So override and new were the two potential answers. So that's great that no one said anything else. Hide is not a keyword. Abstract means something totally different, and we haven't learned about it yet. So I'm glad people said either new or override. Remember the difference here. So override will completely replace the behavior of the virtual method in the derived class. Okay, completely replace it. Even when the variable references the base class. New will replace the behavior, but it only hides it. If the variable is referencing the base class, then even if you said new, you'll still use the old functionality from the base class. Okay, so that's the difference. Very subtle. So yeah, guys, I know chapter 2 is hectic. How they word the questions can be very difficult. But that's why I want to expose you to the types of questions that you'll be asked. I'm glad everyone got at least one right. So that's very, very cool. And yeah, Bill, you did particularly well. You got 4 right. That's pretty great. 4 out of 5. That's good. Chess man, you also did good. Yeah. Okay, nicely done, guys. Nicely done. Okay, hopefully that refreshed our memory. I know we learned a lot last week, so I will even do a little bit more of a refresher. So we learned about the concept of inheritance, and I already went over this a little bit, so hopefully that reminded you guys about what that was doing. We also went over the concept of encapsulation, and here we learned about 3 words in particular, and we briefly discussed another word. So we also discussed this during the quiz, right? So public, that means if you label something as public, it's accessible everywhere. So that is inside the class, inside any other classes, inside any derived classes, everywhere. It's accessible absolutely everywhere. Okay, private means that it's only accessible inside the class that it was created. If you label something as private, only accessible inside that class. Protected, it means that it's accessible inside that class and in any class that inherits from the class. There is also internal, so that just means that it's accessible inside that assembly or project, okay? But we didn't discuss that too much because we won't be working with assemblies or projects much throughout this course. Okay, the next thing we learned about was polymorphism, and there were just 3 words here, but they were pretty subtle, right? So if we mark a method as virtual inside the base class, that means that it will be alterable. You'll be able to change it inside derived classes. There are 2 ways to change a polymorphic method. You can use the word new, which hides the functionality of the virtual method, and you can use the word override, which overwrites the functionality of the virtual method. Okay, and that was all of polymorphism, basically. We actually programmed this up, and we are going to go over what we programmed just after this, just to show you guys the difference again before we move on to abstraction. Because abstraction is actually, it's quite similar. So there's only 2 words that we need to learn about in abstraction, and this is the last of the 4 major OOP concepts. So there was inheritance, which is the ability for base classes to inherit to provide functionality to derived classes. The other way you can say it is the ability of derived classes to inherit functionality or to derive functionality from base classes. We have encapsulation, which is how we protect or create access rights for various functionality and data inside our classes when doing object-oriented programming. We have polymorphism, so the ability of a method to take on many different forms in different derived classes. And we have abstraction, the last of the 4 major OOP concepts. There's just 2 words, and one of them will be familiar. So abstract means make a method unable to define a body, and override means overwrite the functionality of an abstract method. Okay. So I'll show you what this looks like in code, and hopefully that'll make more sense. So I have the example that we programmed last week open in Rex Tester, and I'm just going to go over what the different concepts are over here, just one more time to remind you guys. So last week, we created a polygon class. Okay, a polygon is a many-sided shape, right? Poly, Greek for many, gon, side or corner or something like that. Yeah, probably corner. No, side. Yeah. So we've got a polygon class. All right, a polygon class. It is marked as abstract, which means we can't create a object of type polygon. We can't say polygon poly equals new polygon. This is not allowed. Saying new polygon like this, creating a polygon object, that's not allowed because it's marked abstract. Okay, it's marked abstract. All right, that means we can only really inherit from this class. It's used to inherit from. We've also got two other classes, a rectangle class. So rectangles are a type of polygon, right? So they inherit from the polygon class. We also have a square class, and that also inherits from the polygon class. How do we say something inherits from something? You just put a colon and you type the class name that it inherits from. So this is public class rectangle inheriting from polygon, right? Just to remind you guys. Both square and rectangle are sealed. What that means is I cannot create another class. I cannot say sealed public class, let's say person, whatever, just a random name for a class. I can't say anything else inherits from rectangle. This is not allowed. You are not allowed to inherit from rectangle. The reason you are not allowed to inherit from rectangle is because it's marked sealed. And sealed means that you cannot inherit the functionality of that class. Okay. Cool. So that was the inheritance portion. We also learned a little bit about encapsulation. For example, the length and width of the polygon are labeled as protected, which means I am able to access the length and width variable inside the polygon class, inside any classes that inherit from the polygon class, but I am not able to access length and width outside of those areas, okay? Outside of either the class itself or any classes that inherit from it. There I can't access the length and width. All right. So I know it's a lot. I'm just revising quickly all of the different concepts of loop so that we're all on the same page. And we also covered polymorphism. So we have an area method marked as virtual. What that virtual means is that this area method is polymorphic. It can take on many different forms. So you can see that the area method inside the polygon class says that the area of this polygon is length times width, okay? But it's marked as virtual. So inside the rectangle class, which inherits from polygon, I can say public new void area, which will hide the original implementation of the area method and instead replace it with the area of this rectangle is length times width. Okay, so rectangle instead of polygon. Remember, new hides the functionality, so you can still get to this implementation, the polygon implementation of the area method, because new only hides it away. It doesn't overwrite it. However, the square class overrides the area method with the area of the square is length times width. And so regardless of what you do, if you're in a square object, regardless of what you do, you can never access this implementation of the area method anymore. Yeah. So this is, or lesson 3 of chapter 2, actually, I think. Yeah, lesson 3 of chapter 2, maybe. Cool. Now, last major OOP concept. So that covers inheritance, encapsulation, polymorphism. The last major OOP concept is abstraction. It's quite simple. There is one subtle change, okay? Instead of marking a method as virtual, so you can see I say public virtual void area, and I say the area of this polygon is length times width, right? Instead of marking a method as virtual, I can mark it as abstract, okay? All that means is I am no longer allowed to define the body of this method. What do I mean by body? I mean the things between the curly brackets, okay? This console dot right line, the area of this polygon is length times width. I am no longer allowed to define that, okay? It's just that. Now that might look weird to you, but if you think about what the word abstract means, even in English, it's like a concept, right? An idea. So what this is saying is that the area method is an abstract idea. We haven't got a concrete version of the area method. We don't know yet exactly what it does, okay? We know that if you are a polygon, you have an area. all polygons have some way to calculate their area. We just don't know what that way is yet. Okay. So the polygon class is not defining the area method at all. Okay. It just says that there is an abstract idea called area that you can define. All right. Or actually that you have to define. If you are a polygon, you have to tell it how to calculate your area. Okay. Now, so since we've marked it as abstract area, square, the square class, which inherits from polygon, has to define its implementation of the area method, because the area method is abstract. It's an idea that all polygons have, but it hasn't specified a concrete version of the area method. So the square class has to define an area method. It does this already with override. Okay? It defines, the square defines its own version of the area method. Okay? So square is actually okay here. The only question left is rectangle. So rectangle uses the term public new void area. So it's saying, oh no, I have a new implementation of the area method. Currently, that's what it's saying. So it's hiding the original implementation, is what we learned about in polymorphism. However, now, because it's not marked as virtual, remember when we marked it as virtual, we had a body. So that's what it looked like when it was marked as virtual. It had a body, right? Now there is no body. There is no implementation to hide. There is no way you can define a new implementation because there was no old implementation, okay? So you can, the only difference with marking it as abstract instead of virtual is that you can no longer, the word new is no longer possible, okay? Because you can't hide it. You have to replace it. You have to override it. And so we have to say public override void area and then define the rectangle area. And that's it. That's all abstraction changes. Okay. We have the word abstract and we have the word override. Okay. The word override means the same thing as it does in polymorphism. The only thing is that you can't use the word new because there is no old implementation to hide. Okay. And that's it for the 4 major concepts of OOP. And yeah, I know chapter 2 is, it's hectic. There are a lot of new words to learn. But what I want to convince you of is that there's no singular word that you don't know the meaning of. Okay. It's like together they can become fairly complex and how these words interact with each other. But each word in and of itself is fairly simple to understand, right? And I can give you, we can go through some more examples, right? So the word sealed just means that I am not allowed to inherit, I'm not allowed to derive from this rectangle class. That's all sealed means. It's not too complicated. It might be difficult to remember that sealed means that. And that's the trick with chapter 2. There's a lot of new words that you have to remember. The word override just means, okay, I am overriding the area method. That means in the class I derive from, there must be an area method that is either abstract or virtual that I am overwriting, right? That's all it means. It's not too complicated in and of itself, but its relationship to other words can get quite complicated. And that's what chapter 2 is testing, guys. Your ability to understand the logic of each word and how it fits into this greater idea of object-oriented programming. The word protected, it's not too complicated to understand. It's a part of encapsulation. That means that the length variable, and this is just basically a variable, we call it a property because it's inside a class and it has these getters and setters, and we know what getters and setters are. So protected, that just means it's accessible inside the class and in anything that derives from the class, okay? Again, as an idea, protected, not too complicated. It's just that there is a lot of words, okay? So yeah, that's the main thing about chapter 2. There's lots of words. The questions they can ask are very subtle, but just know that each word in and of itself is not that complicated to understand, okay? It's just that they're a part of this greater whole, and there are a lot of words to know. Okay. So abstraction means that we can define a method without providing a concrete implementation, without providing a body for the method. Okay, we can define a method as an abstract idea. And this will come up again a little bit later, so we will be able to get more time with the idea. And that is it for the 4 major OOP concepts, okay? The 4 major object-oriented programming concepts are inheritance, polymorphism, abstraction, and encapsulation. Okay. Today, we'll be moving on to some fairly interesting ideas. So I am going to save our full, so in this Rex tester here, we've demonstrated every single major object-oriented programming concept. I'll share it in the description of the YouTube video and on the WhatsApp group so that you can go back and revise it. Okay, so I've saved it and I'll share it. All right, cool. And we can now leave that. We're going to start a new code base. So nice, we're starting again fresh, and we'll, yeah, the content from today is not, it is still object-oriented programming. It falls under that grouping, but it is slightly, it's different. So we're getting almost like a fresh start, and we'll learn about these ideas now. And we're starting with something really cool that will really improve your intuition of how computers work and what exactly is going on in a computer's memory. Okay. So yeah, the main topic of today's lecture is memory and events. And I'll explain how they are subtly related towards the end of the lecture. Okay. So at first, I want to remind you guys about methods. All right, we've done this quite a few times before. So a method can define specific behavior inside a class, or it's just used to define specific behavior. So let's just quickly create a method just to see a simple example of this. So what I'm going to do is I'm going to create a method, public static void, let's say multiply by 2. Okay, very simple method. All this is going to do is take in a number, integer called a, and it's going to output 2 times that number. So console.writeLine, console.write a times 2. Okay. So when I use this, you can see I can go a equal, I can just say int x equals 6. I can say multiply 2x. Okay. And when I run this, sorry, let me just see. Cannot directly contain members such as, I didn't put it in the class, silly me. Okay, I was trying to put it in the namespace, sillily. Okay, there we go. Sorry about that, guys. And there we go. So it outputs 12 as you'd expect. Okay, so we say int x equals 6, multiply 2x. Okay, so we give it x, our integer x. That goes in, it gets saved in an integer called a. It goes into multiply 2, referenced by that name. And then it just prints out a times 2. Okay. Very simple method. We don't need a complicated method to demonstrate today's topic though. So that's cool. So that's methods, right? We've covered them quite a few times. So a method has a name, and you can use that name to reference that method, right? So here I say function x, and you can see that the name of the method corresponds. So that's how the computer identifies where it must go, what you're trying to do. Okay. You also give it a variable. So int x equals 3, that gets passed in, that x variable gets passed into the function method. and that's the one it uses in place of a inside the function, called function in this case. Now, there are two different important ideas here, because how the computer passes x to function, because we say int x equals 3, function x, and static in function saves it in a variable called a. How does that process occur? How does the computer do that? In what way? What is the logic of that? Like how is x being passed to function? Because the computer has memory, right? So we can be more specific about how this is working. And the answer is actually that there are two different ways that a computer can do this. And you'll see that this really exposes something quite interesting about computing, like how memory works. The two different ways a variable can be passed are pass by value and pass by reference. Okay? Pass by value and pass by reference. So I'll just quickly demonstrate this. All right. So let's consider the first way, passing by value. This is probably the more intuitive way that you would think about it, approaching it from like maths, for example. So pass by value literally just makes a copy of the variable inside the method. Okay? So I'm going to demonstrate it with sort of similarly to how we went through the while loop. Okay? So I've got memory in the bottom right here. So I'm just giving, obviously this is an oversimplification of how the computer's memory is working. So we have addresses. So that's what the hashtags are. So hashtag 0 is like address 0. Hashtag 1 is address 1 in memory. Hashtag 2 is address 2 in memory. Hashtag 3 is address 3 in memory. Okay, so I'll refer to that address 0, address 1, address 2, address 3. In address 0, I might have my browser open or anything, any application. In address 1, we maybe have the main method, right? Like the main method where our code starts running, where our C# code starts running. That's the main method. Okay. And yeah, you can imagine the computer's memory in practice is much larger than this, and a lot can be going on. But for the sake of our example here, address 2 and address 3 are empty. And what we're going to see is when we run each line, what exactly occurs. So yeah, what exactly is going on as we run each line. Similarly to how we went through the while loop example. So the lines are going to appear on the right of my screen here. So let's take this first line. Int number equals 6. Int number equals 6, right? Int number equals 6. What does that do? In the second address space, so it finds an empty address space that is able to hold an integer. It says, all right, the word number is pointing to this address space and it holds the number 6 there. Okay. So that's sort of creating that variable. We've got the word number, and that points to the address that is holding 6, holding the number 6. Okay. So that's that first line, int number equals 6. Hopefully we get that now already. This is just one way of representing it, but that's just creating a variable, right? No need to overcomplicate it. The next part, we say function number. Okay. So we are passing, we have a function called function, and we are passing the variable number into function. So how does that work? How does the computer do it? What it does is it finds another empty space in memory. So in this case, address space 3 was empty. And when I call function number, what it does is it creates a copy at that address space. Okay, it creates a copy at that address space, that next empty address space, and it saves 6 in that copy. And that copy of number is what we give to function. Okay? We give function the copy of the variable. We don't give function the number variable itself. We give it a copy. Okay? So this might seem very abstract to you and you might go like, okay, but like, why does this matter? Of course you give it a copy. But what I want to show you is how it practically affects how you program things. Okay, so let's go back to Rex Tester and actually program this up and see how this might work versus how it does work. Okay, so I'm going to show you, let me just show you that now. Okay. So we are in main in Rex Tester. Okay, so you can see that here. I'm going to change it so that it's more in line with what we have in the example. So we have public static void function int a. Okay, int a. I'm going to call this int copy just to be more explicit. Okay, so this is the copy. This is the copy. Okay, I say int number equals 6. So we know that goes and finds a space in memory. It points number, the word number points to that space in memory, and we save 6 at that space. We can then say function number. Function number. Okay. What I want to show you is that when I edit the variable called copy, and it doesn't matter what it was called, even if it was called number, I can call it number as well. Okay. When I edit this variable, number outside the method does not change. Okay. So what I'm going to do is I'm going to say console.writeLine number. So I'm just going to print out number. Okay. And I'm also going to, so inside the method called function, I'm going to say number equals number plus 6. So I am adding 6 to number. Okay, I'm adding 6 to number. In fact, we can make it more extreme. I'll say number equals number times number. So I'm raising number to the power of 2. I'm multiplying it by itself. And then I'm going to print out number. Okay. So let's go through and see what this might do. All right. So I'm going to say int number equals 6, function number. Okay, so the method is called function. There it is. Okay. We give it number. As we just saw, the computer will create a copy of number. Okay, it's now inside the function called number. It'll say number equals number times number. So that is 6 times 6, so 36. And it'll print out 36. We then go back here and we print out number. You'll see that it will print out 6 because it is working on a copy. The function method is working on a copy, not the original. So let me actually run this. You see it prints out 36, 6. 36, 6. So hopefully that makes sense. The number that exists inside the function method, this number is a copy of the original variable. So copy equals copy times number. And then we print out copy. Okay. So copy equals copy times copy, and we print out copy. Okay. So it doesn't actually change outside of the variable. Outside of the method. Okay. So do you understand how, like, those variables, they are connected in a way, but copy is a copy of number. It is not number itself. And hopefully you can see that that's not necessarily obvious that the computer would do that, right? Make a copy of number instead of use the number itself. Okay. Hopefully that makes sense. Let's see the alternative, and then maybe you'll be able to position this idea better in your mind. So this is called passing by value, because we are just passing the value, that is 6, to the method. We are not passing the reference. We are not passing number to the method. We are passing the value 6 to the method. We're making a copy of 6 into another place, and we are passing that value to the method. We're not passing the actual variable name, the reference, to the address. We are not passing that reference to the variable, to the method. The alternative is to pass by reference. Okay? The alternative is to pass by reference. So we're literally going to go through basically the same example, but it'll be subtly different, very subtly different. Okay. So I've got the same sort of idea of memory in the bottom right. So memory and address space 2 is empty again, and memory and address space 3 is empty again. All right. We say int number equals 6. So at address space 2, we create number. That's the same as last time. That's the same as last time. What we do now is instead of calling function on number, I'm going to call function on ref number. So what ref stands for is reference. What ref stands for is reference. And now instead of passing a copy of number, it will pass a reference to number. So it'll pass the number variable itself. So this, the address space, number 2, that is what we give to the function method. Okay. So again, what does this mean practically? Let's see how this is different. So all I have to do is add 2 words to this example. I'm going to say, so int number equals 6, that'll stay the same. I'm going to say function ref. See, it highlights ref. That's a keyword. C# knows that word. It stands for reference. And then I'm going to tell function that what it is receiving is a reference to an integer that it is going to call copy. Okay. Now, when I run this, you'll see how it differs. You see it now prints 36, 36. Okay. It's a very subtle difference, guys. I know it is it's pretty strange. Like when I first learned this, it's quite crazy. And this is like first year computer science, and even second year computer science a little bit. You spend some time learning about pass by reference versus pass by value. But yeah, we can pull the band-aid off now, I guess. So int number equals 6, function ref number. Okay, so this was just passing the actual number variable into function. So hopefully you guys understand what's going on there. If you don't, please do say. So now this is no longer a copy. This is number itself. The actual number variable was passed into this method. And so when I say number equals number times number, it isn't just editing a copy. It edits the version of number that we created over here. Okay. All right, hopefully that makes sense. And feel free to ask if you're still worried. Okay, so we've learned a bit about this idea of passing by reference versus passing by value. And just before we take a break and then move on to events in a bit, I just want to explain some subtleties that you guys should know. So all objects in C# are passed by reference, all of them. Okay, all objects in C# are passed by reference. So I'll show you that quickly. I am going to create another class quickly. So I'll say public class rectangle. And I'm going to give it an integer length, or public int length, and public int width. Okay. I am going to create an object of type rectangle over here. So I'm going to say rectangle rect equals new rectangle. I'm going to set rect's length to 10 and rect's width to 5. Okay. I am going to create so this function, I'm going to change it a little bit. instead of taking in a reference to an integer, remember when we create a class, we are just creating our own type. So I'm going to say that this function takes in rectangles, takes in a thing of type rectangle, and it calls it rect. And what it is going to do is it's going to change the length. So it's going to double the length of the rectangle, for example. So it's going to say rect length equals rect.length times 2. Okay. And I'm just going to print out what rect.length is after calling this method. So I'll say rect.length. I'm going to print it out here. And I'm just going to call the method on rect. So I'm going to say function rect. Okay. Now let's see what the length of this rectangle is at the end of this running. Yeah, definitely. So AB, I had this with AP Maths. I would say that this is similar to like okay, wait, we'll discuss this on the break, but I do want to just finish this. In fact, can one of you tell me, from what I've just told you, that a rectangle is passed by, that objects, all objects are passed by reference. What will the value of length be when I print it out on this line? Before I print it out, can any of you tell me? It's initially 10. I passed it to a function.
Will it be 100?
Will it be 100? Remember, I don't
Yes.
say rect.length times 10. I say by times 2. Okay?
20.
Right. If it was rect.length equals rect.length times rect.length, then it would be 100. Okay.
Oh, so it's 20.
So it's 20, exactly. And the important thing to notice here is that rectangle rect, okay, rect is being passed into function by reference. So even though I create an object over here, function is not getting a copy of rect. It is getting rect itself, okay? It is getting the actual variable rect. So you see, all objects are passed by reference. Okay? If you don't want your object to be passed by reference, and they do ask about this, guys. It's a super subtle difference. It's the last thing I'm going to mention before, or pretty much the last thing I'll mention before we take a break. Instead of calling it a class, you can call it a struct. A struct. Okay. Let me just see. We might have to make. So yeah, instead of calling it a class, you can call it a struct. Okay. And the difference between classes and struct, you see when it's class, rectangle length is 20 when I print it out here, because function, when it says rect.length equals rect.length times 2, if it is a class, it is not editing a copy. It is editing the original. Okay? If I call it a struct, then instead of being passed by reference, it is passed by value. Okay? So you have to remember, structs are passed by value. Classes are passed by reference. Okay, subtle difference, very subtle, but yeah, hopefully you get it. And again, I'll give you guys access to all of these examples so you can play with them yourselves. The other thing to note is arrays, collections. So all arrays, lists of things, are objects. Okay, so all objects are passed by reference, and arrays are objects. So let me, this one, hopefully, this will let me know if you guys understand. So I will show you. I will show you. And yeah, this one you guys are gonna answer because I've been talking our heads off here. So I'm gonna create a list of numbers called numbers. And I'm gonna set this list equal to 2, 4, 6. Okay. I'm going to say function takes in a list of integers that it calls nums. I'm going to change nums in position 1 to 8. Okay, and I'm going to give function the list of numbers, and I'm going to print out numbers in position 1. Numbers in position 1, sorry. Can someone tell me what will print out when I run this code? So numbers in position 1, and we can go through it line by line if we need. So on this first line here, I have a list of numbers. It holds 2, 4, 6. Currently, guys, if I access numbers in position, okay, Chris seems to be on point. So that's good. Yeah, that's correct. Why is that correct? Because arrays are objects. Arrays are objects, which means they are passed by reference. So the function method is not editing a copy, it is editing the original. And so you can see that the array called numbers, even though here it's declared 2, 4, 6, I am not editing a copy in this. When I say nums in position 1 equals 8, I'm not editing a copy, I'm editing the original. And so the 4 is changed to an 8 over here. Okay, cool. And yeah, cool. That's actually enough. You don't need to know these last two notes really. I mean, I guess it is good practice to know that. So yeah, all normal variables. So that is integers, chars, doubles. They are passed by value. So the method will get a copy of them unless the reference keyword is used. Like I showed you in the slide earlier on, unless you use the reference keyword, it is passed by value. Okay. In general, you should not use the reference keyword because it makes your code very difficult to understand, because it's difficult to know if something is being passed by value or passed by copy. Okay. So in general, just use whatever C# does, leave it that way. The last thing I want to leave you guys with on this, and then we'll take a little break. Sorry, I know I've cut into the break a little bit. Why are objects passed by reference instead of being passed by copy? Can anyone tell me, do you have intuition about why that difference would exist? Why would we want to pass objects? So like one integer, if it's int number equals 6. In this case, if I just pass number to function, that is passing a copy. I make a copy of 8, so I use up some memory and I make a copy of 8 and I pass that copy to the function, okay? So I pass that copy to the function. But why, when it's a list of numbers, does C# decide that, oh no, now we must pass it by reference, we mustn't make a copy? You guys have an intuition as to why C# doesn't want to make copies of objects? It's okay making a copy of one integer, but it doesn't want to make a copy of a list of integers. Why do you think that is? Why did they do that? It seems to make things more confusing, right? But why do you think they did that? Does anyone have an intuition? And that's why I said this is maybe a difficult concept to understand, but it's nice to learn about this because it'll give you a better understanding of how computers function. Okay, I'll tell you, and then hopefully it'll be like maybe a bit of a revelation, if you like. So the reason C# does not pass objects by copy is because objects are large. That's the simple way of saying it. You can imagine if I have a list of 1 million integers, right? Like it just goes on and on and on and on and on and on. If I have a gigantic array of integers, C# does not want to make a copy of that entire list to pass to a function, which makes sense. It'll just pass that list itself so that it doesn't have to make a copy, because making a copy will use up a huge amount of memory. Okay, so that's the difference: pass by reference versus pass by value. The reason we pass objects by reference is because we don't want to have to make copies of them because they're big, right? Like a rectangle has a lot of stuff, right? Length, width, and an area method. We don't want to make copies of all of this stuff. We just want to pass the original. Okay, cool. Hopefully that makes sense. And when we come back, we'll go back to OOP. I'll give us like a 9-minute break until 10:10. And while we're on break, ABL, I'll answer your question. So AB asked, could this course help us in future? Maybe if I wanted to study a specific career in university and didn't take CAT nor IT as a subject during my high school. Hopefully this makes sense. So yes, definitely. If you plan on studying computer science or information systems at university, you'll basically be finished with what you learn in first year in both of those courses. So you're basically, at the end of this course, you'll be done with first year computer science and information systems. And that's quite nice because you must remember at university, you take lots of courses, okay? So in first year, you'll usually take 4 different courses. So in my first year at WITS, I took physics, maths, computer science, and actually I forgot, and computational and applied maths. So those are the 4 courses I took in first year at WITS. And what was cool is that at school, I did AP maths, which means that all of first year university maths I had done before, which means that I had more time to, because there's a lot going on, like when you start varsity, it's like a pretty high pressure thing, but there's also a lot of freedom. You want to socialize and stuff. So it means you free up some time by having already covered a lot of what you would learn in maths. And in this case, if you took computer science or information systems at university, you'll already know all of first year, which means you'll have more time to focus on your other subjects, and you'll have more time to, socialize and take a break, which is nice. It's very nice. Some universities, I know WITS doesn't, but some universities will also consider extra certificates as a part of your application. But WITS usually doesn't. They will ask you for them, but as far as I know from the application process, they don't actually look at like your extramural activities and stuff much, which is weird. WITS is one of the few universities that does that, like doesn't look at those extramurals and stuff. But yeah, it is the way it is, I suppose. Cool. Hopefully that answers your question, AB. Let me see. Yeah, cool. Yeah, no problems. But yeah, it's definitely good to take, if you're planning on going to varsity and studying tough subjects, it's definitely good to take like some extra classes, because it will really reduce the amounts of pressure. Because that is a big thing about varsity, is that they actually just give you too much. There's just too much to learn. And that's what makes it difficult. Like first year maths is not difficult in and of itself if you have enough time to learn it, like you do in like grade 11 and matric. But at varsity, there's just so much. So that's usually how they break students. But if you're familiar with some of the course content already, that subject will just be easy for you. Like if you take computer science after doing this course, first year comp sci will just be easy. You won't have to work at all basically for it. And it's also just nice having the MTA if you want to go work at Microsoft or do your MCSA. So your MCSAs are very good to have. The MTA itself, it will help with some jobs. Like if you're going for a technical job and you have the same same CV as someone else, then having the MTA can set you apart. But like the MCSA in particular will get you a dev job by itself.
So when are we gonna write this exam?
If you join this class, Taffy, we're not sure. We're trying to finish all the course content by the end of November.
Okay.
So yeah, but if you stick with Bryanston, then you'll write at like the middle to the end of November is when we want Bryanston to write the exam. This class, we're not sure yet exactly when they'll write, but it looks like also on track for sort of November. Yeah. But we'll move through the content with this class a little bit faster. So I'm gonna go have some water quickly and then I'll be back and we'll get started again. Okay, I'm back. You just have events and interfaces left in chapter 2. Events are quite difficult. Interfaces are very fun because when we learn about interfaces, how we do it is we're going to create a text-based adventure game. So like you're going to be able to pick a weapon and pick an enemy to fight and then hit that enemy with the weapon. And we're going to do that with interfaces. And then we'll be done with chapter 2. And yeah, guys, chapter 2 is scary. It's scary. It's a big chapter. It's a difficult chapter. So, you know, give yourself a pat on the back for getting through it, especially if it's going at all well for you. But yeah, it is a tough one. But it's mostly tough not because each content is difficult. So Chris is asking about the MCSA. I think the MTA is actually the only requirement. If you have the MTA, you'll be allowed to write the MCSA. And yeah, the MCSA is difficult. They ask you practical programming questions. But I think, yeah, I mean, it's worth doing. I think I'm gonna go get my MCSA probably next year sometime, when I have some free time. But it's cool. You can like pick a programming language, so you can do it in like HTML and JavaScript. You can do it in C#. You can do it. Have a bunch of options, and you pick one, and you just, yeah, similar. It's basically the MTA, except the questions are more difficult. So like a step up. And then after the MCSA, they have the MCSE, and then they have the MCSM. So it's like there's Microsoft Technology Associate, then MCSA, I think, is Microsoft Certified Solutions Architect or Associate, I think. And then MCSE is Microsoft Certified Solution Expert. And then MCSM is Microsoft Certified Solution Master. And so like it's like leveling up, basically. It's quite cool.
So once we've done this course, what type of jobs do you think we can get?
So with the MTA on its own, I think, so it's this kind of thing that, you know, can set you apart. Like, you know, if you were in A-team hockey at school, some company might go, oh, that's quite nice if the person likes hockey, for example, and they might hire you over someone else. And so the MTA will kind of serve as that kind of function, where it's like, it might just set you apart from other candidates. But to the point of this in particular getting you, I mean, there are definitely things like if you are looking to go into, particularly if you're going to go work for Microsoft or for any Microsoft partner, and there are lots of Microsoft partners. They have like a whole tier system, but like any Microsoft partner will like to hire you. A lot of banks will have like desktop technicians. They'll frequently hire desktop technicians, and the MTA could definitely land you a job like that. But yeah, I mean, so that kind of thing, maybe if for like communications support type of thing, the MTA in particular could get you that. But I think it's more as like something that can set you apart, you know, from other candidates.
Oh, thank you, sir.
Yeah, no problem. Okay, let's get started with, I want to get through chapter 2. It even freaks me out teaching chapter 2 because it's quite hectic. All right. So if you guys remember when I introduced the idea of object-oriented programming, we started by saying we gave this naive, and don't get me wrong, I know it is very naive to think of the entire world in this way, but obviously we have to simplify things if we are going to be able to program them, because we can't program all of the complexity of the universe, right? So we have this naive definition of the world. The world contains a bunch of things, which we're just calling objects, that interact with each other simultaneously. And our goal with object-oriented programming is to somehow incorporate that idea of objects interacting with each other simultaneously into the code that we write. That was our goal with object-oriented programming, okay? So we now know how to create objects, and we can give those objects behaviors, and we can give them attributes. So we can create objects pretty well using the ideas of OOP that we have already learned, okay? But what about this point of that interact with each other simultaneously? We haven't yet explored like the simultaneous action, right? We've got methods which we might be able to use, right? So this idea of interacting simultaneously, we've got methods that might be able to do something like this, but they're not exactly there yet, right? We can definitely flesh out this idea a little bit more and expand on it. And that's kind of what events are about. Okay? So in order to explore this idea a little bit more, what we're going to do, and I think this is it's a nice way of, like when I was told that I needed to teach events to some people who didn't have prior programming experience, I was like, wow, this is going to be tough. But I think this was the nicest way that I saw in like my sort of exploration of the different ways to teach this, of explaining events. And that was in creating a video uploading app. Okay, so almost like YouTube. Okay, so what we're going to do is explore creating our own small version of YouTube. Okay, and it's going to be extremely simplistic. It's going to be literally one Rex tester file, but hopefully it'll give you an idea of why events and delegates are important. Okay, so we're going to have a content creator with, actually, you know, I've got 25 subscribers now, or 27 or something. So more than 25 adoring fans now. But cool. So what do we have? What parties? So remember, we've got objects that need to interact with each other. So let's think about this in the context of YouTube, right? We have subscribers, we have a content creator, and we have, you know, us, YouTube. So the content creator will upload some new exciting content about C# events and delegates. And at some point, we have to notify the subscribers that this content has been uploaded. Maybe we don't have to notify them necessarily, but we have to somehow get the information across to the subscribers that, whether it's appearing in a list or something, that a video has been uploaded. Okay. So this is like a simplistic view of the interaction. We have three objects, right? We have subscriber, we have creators, and we have us, all right? Or more like the video itself. The content itself is hosted on our server. So that's like our third object, okay? So how would we do this? So yeah, what I want to explain is we've got a certain idea about object-oriented programming now, right? Where we can probably define this structure. We can at least attempt to create this, okay? How would we do it? And after we do it, I want to explain to you guys why YouTube wouldn't do it in that way and show you how they do it. Okay. So yeah, let's get started on that. We're going to use our current knowledge of classes and methods and stuff like that to create this basic structure. Okay. So where we're going to start is, I'm actually going to get a fresh Rex tester open. Okay, there we go. Where we're going to start, I think it makes sense to start with the video, okay, the content. That's a sensible place to start. We're a site where you can watch videos, so we need to start with the video. So we're going to upload a video. What's the first thing I need in that idea, guys? To upload videos, what's something sensible that I need? Like at a very basic level, what's probably like the simplest thing I need in order to upload a video? It's almost a silly question. I don't even know why I'm asking. The first thing we need is a video. Okay, first thing we need is videos. And how are we going to create a video in our idea of object-oriented programming? We're going to create a video class, right? Everything's a class in object-oriented programming. Everything. The subscribers will be a class. The videos will be a class. The uploader will be a class. All of these things will be classes. So we're going to create a public class video. Okay. And we know how to do that. Okay, that's simple. There's nothing new there. Okay, you guys know what that means. We're creating a class called video. what will what properties, what attributes might a video have? I'm going to propose a simple one. I'm going to just create a video name, a title for our video. Okay, what type am I going to use to store the title of my video, guys? Just to make sure you're awake.
Sorry, so what is the question?
What type am I going to use to store the title of my video, the video name?
So I think it's MP3 or MP4.
That I would use to store an actual video. Maybe I'd store in an MP4 type file. But how would what am I going to use to store the video's name? What type will I use to store the video's name?
Title.
Yeah. Okay, Clark says string, and that's correct. So we are going to use a string to store the title of the video, okay? Public string. Okay, and I'm going to call it the video's name. Okay, title. I'll call it title. That makes sense. Some other things that you might want to associate with a video are like its length, right? You might want to know the length of the video. Obviously, you want the MP4 file itself. How you would probably do that is you would create a public string URL, and you'll actually just store the URL of the video, and you'll just save the video somewhere on a server. Okay, that's how you would probably do it in the real world. But remember, we're keeping things super simple, okay? We're not looking to actually create a thing where you can watch videos. We're looking to understand the flow of this, okay? So we have a class called video, and you guys can see how we could add things to this class, right? Practically, adding things in that way can be difficult, right? You will need a Boolean, for example. We might need some Booleans. We could say public bool, like, is this age rated? Like, is this video age rated? You know, like when you upload a YouTube video, YouTube will ask you, is this made for kids or is it made for adults? Okay. So there are lots of things like that that we might want to add to our video class, but hopefully you guys can see that's just adding more fields, right? Adding more variables, and you guys know how to create variables. Okay, you just give the type and the name. Not too bad. What next do we need, guys? So I need to be able to create a video. What structure can I put in my class that'll allow me to create or initialize a new variable? What do we call that structure? That'll allow me to initialize a new video. I'll give you a little hint. It's a special kind of method. You guys do know the word. We would have heard it in our first lecture of object-oriented programming. Special kind of method. Clark, cool. You're on point. That's awesome. Yeah. So we'll create a constructor. The special rule about constructors. So constructors are where we initialize new objects, okay, where we create new objects, or when we initialize the attributes of a new object. So we are going to create a constructor for the video class. The special rule about constructors is that they have the same name as the class in which they are in. In this case, so my video class is very simple. I've just got a title for my video. All I've got is a title. And so what I need, all I need, is a single string. Okay, my constructor just needs a single string, which I'm going to call title, that to set the title to. So you have to give this constructor one variable. Okay, and then the next thing is to just set the title of the video to the title that the constructor is given. You can see that the names are the same, guys. Public string title, string title. So what keyword can I use to differentiate between the two title variables that I have? Because we have a title inside the video and we have a title coming into the constructor. How does my constructor differentiate between the two? Does anyone remember what keyword I would use? Give you some time. How will I identify the object that I am in? What keyword will identify the object? Yes, Chris, exactly this. Okay, this, exactly. Cool, so we'll say this dot title, so that is the title of the video, is going to be equal the title that the constructor is given. Okay, this dot title equals title. All right, and there we go. I've now got a very simple video class, and you guys can picture adding much more stuff to this. Okay, there can be a lot more. But as a simple starting point, this is fine. We can now create objects of type video. Okay, so I'm going to create an object of type video. I'm going to say video vid equals new video. Okay, and I have to give the video a title. So I'm just going to call mine C# events and delegates. Or that's not all we learned today. We also learned about memory. So I'll say C# memory events and delegates. Okay, something like that. Okay, so that's the title of my video. I've now created a new video. I've given it a title, and C# will create that. In order to just double check that this is working, what I'm going to do now is console.write vid.title. Okay, vid.title, and you can see when I run this, it prints out C# memory events and delegates. So we've successfully created an object of type video. Okay. The next thing now, so let's see what we've done. We'll go through the diagram. Okay. So we now have an idea of a video, so uploads new content. So we've got the content down. We know how to create new content. We can create new videos now. How do we upload it? How do we create the logic for uploading it? Okay. So how do we create that logic for uploading a video? Remember, during like professional development, when you're actually developing like a website or something, basically everything is a class. Yeah, okay, Clark, exactly. Video uploader will be a method. So there will be a method called upload, is rather what I should say. There will be a method called upload, because you're right, uploading is behavior, right? But practically when developing things, we always create a new class for everything. Like, it's almost strange how many classes there are. But how YouTube would do this is that they would create a class, public class video uploader, something like that. Okay. Why would they do this? It's just a useful grouping. Okay, you can picture if you're a developer at Google or at some big tech company, it would be very difficult to keep track of where everything is. So let's say you're given the job of developing a new video uploader. You need to modify the video uploader in some way, and you're at Google. You can imagine their code base is gigantic. There are thousands of files, probably upwards of 1 million lines of code across all of their different applications. There is a huge amount of content there. How do you find, in particular, what you need to edit? The answer is there'll be a file somewhere, and actually probably multiple files in the case of like YouTube, where that will deal with video uploading, and each file will just hold that one class. There'll be an entire file just holding the video uploader class. And so if you're tasked with improving that aspect of the code, you'll know exactly where to find it. Okay. Cool, but you're correct. Uploading is behavior, so it will be defined in a method. I'm going to call my uploading method, quite simply, I'm just going to call it upload. Okay, I'm just going to call it upload. So what we'll say is public void upload. Okay, cool. So that's it. That's my upload method. What do you think this upload method will take in, guys? Does anyone have any ideas? So this upload method is going to upload a video, right? So what will it take in? What will it expect to be given?
MP4.
Video
Yeah,
file.
so practically, remember though, we've got all of these content, all of that kind of stuff. So in this case, we've just got our title, right? That's our only attribute. But you can imagine having more like URLs and all of those kinds of things. But we've got a class called video, right? That holds all the details about a video. We now need to upload it. So what will the upload method expect? We now need to actually go ahead and upload that video. So let me remind you that when we create a class, we are creating our own type. So you know that inside methods, we can say that this method takes in a string. We can say it takes in an int. Okay, I think it's just broken mic or something. Okay, we can take in a string, we can take in an int, we can take in any type. So what do you think our upload method will take in this case? What type will it take in? Bearing in mind that when we create a class, we create our own type. Anyone have any ideas? Okay, I'll spoil it, but I think it'll make sense once you see it. Our video uploader is going to take in a thing of type video. Okay, so it takes in a video vid because the class video holds all the information we need about the video. So our uploader class, our upload method just needs to take in that vid. Okay, cool. So hopefully that makes sense. So our upload method is just taking in a video vid, and it's just going to upload the video. Again, we don't care about the actual technical level of how you upload a video. It's not relevant to our understanding or our learning of events and delegates. What we care about is kind of like simulating the process. We care about the process that this goes through. So our upload method, again, is just going to be super simple. We're going to say console.writeLine. And I'm just going to print out uploading uploading, and then I'm going to print out the name of the video. Okay, so I'll say vid.title rather. Okay. And so what I'm going to do, I'm going to create the new vid. So I say video vid equals new video. And then I'm going to call video uploader. Before I do that, I'm going to need, remember, this is not static. It's not static. It's not static. So I'm going to have to create a thing of type video uploader. So I'll say video uploader equals new video uploader. So that's just me creating a video uploader object. Okay. Again, guys, it might look scary, but you know what this is doing. It's just creating a thing of type video uploader called uploader, and it's saving a new video uploader. It's exactly the same as when we created a new video, except video uploader has no constructor, so we don't have to give it any values. Okay. And then I'm just going to call uploader.upload. And what am I going to give it, guys? So I've created a new video. How do I give it upload what it expects? What am I going to give upload? Looking at the code that comes before upload, what am I going to type next in these brackets? I'm interested to see if anyone can see. So we say video vid equals new video. So that's us creating a video object called vid, right? We created a video called vid on that line. We then say video uploader equals new video uploader. And I want to say uploader.upload. What does it expect? Uploader.upload expects a video. It expects us to give it a video. What is the video called, guys? What is the video inside our main method called? What do I give upload?
Isn't it vid?
It's vid, exactly. Cool. I'm glad That means we're following. I hope you guys could all, even if you weren't confident enough to say it, I hope you guys could all see what I was typing next, okay? Because that does show like a level of understanding. You just predicted what I was going to type, okay? So that's cool. Okay, uploader.upload vid. Okay, so then I'm just gonna run this and let's see what happens. Okay, so now it prints out uploading C# memory events and delegates. Cool. So that's a pretty good attempt that we've got there. I do want to see, can we say like, ooh, maybe we can use system.console. Sorry guys, I do want to see if we can like, forget the, because this can be quite nice. We can make it look quite realistic. So I'm just, that seems quite nice. So let me, I'll use that. Cool. So that will just make it sleep for a second. Okay. So let me see if we. Okay. Oh, unfortunately, I do remember this. Yeah, because now it'll only print out the uploading. Okay. So now it waits 3 seconds. Okay. Cool. Yeah. No, we won't do that because Rex Tester doesn't handle the input the same way console does. That's unfortunate. But it's okay. So you can picture it uploads the video at that step. So it goes console.writeLine, uploading vid.title. So that's cool. We can then start going, what happens now after we've uploaded a video? So what we've got now is this process is done, this process on the left. We can create new content. We can create a new video. We give it a title. And we can upload that content, right? By calling video uploader.upload, right? Video uploader.upload. We have this method that uploads the video. Again, in like a simplified way, but this is the structure. This is like the flow of the logic. The actual technical aspect of it is not relevant, really. Okay. The next step is to go ahead and notify the subscribers. So before I can notify subscribers, what do I have to add to my code, guys? What do I have to add to the code that we have so far? Anyone know? What will I be adding next? So let's see. We have a class called video. We have a class that is a video uploader. Okay. We now want to go ahead and notify subscribers.
Notification.
Yeah, I suppose that's a good way of a good plan. But I think even on a more basic level, again, it's almost silly to ask. Before I can notify subscribers, I have to have subscribers, right? So how can I add subscribers to this app? What will I add?
Promotion.
Well, so we have a class called video, right? So we have a class for videos. We also need a class for subscribers, right? We need a class for subscribers as well. So I'm going to go and create that subscriber class. Again, it's just going to be super simple. We won't actually store any details about subscribers, but I want you guys to be able to visualize that we would be able to do it, right? We would be able to do it. Okay. So we are going to create a subscriber class. So that'll just be public class subscriber. Okay. And the actual act of notifying a subscriber, that's a behavior. So we're going to add that in a method. Okay, so I'm going to say public void notify subs. Okay, simple method. And it's just going to say, a video has been uploaded. Okay, a video has been uploaded. So that's all notify subs does. It's just a method that prints out a video has been uploaded. All right. What we can do now is from the upload method inside the video uploader, after a video is uploaded, we're going to call another method in the video uploader called uploaded. Okay, you could just do it here, right? You could do whatever logic you want here, but it's neater to separate it out. So we have a method that uploads, and we have a method that handles everything that should happen after it uploads. And I'm just going to call that method uploaded, okay, past tense. Okay, something like that. What this is going to do is it's going to say, all right, after a video is uploaded by upload, okay, so public void upload, and we give it the vid to upload. After that's done, this is just going to call uploaded. Okay, like that, uploaded. And all uploaded will do is go ahead and notify the subscribers. To do that, it's going to have to create a subscriber object. So it's going to have to say subscriber sub equals new subscriber. And you can imagine this would be handled slightly differently, but it's fairly sufficient for now, just for the sake of our example. And then it calls sub.notify subs, which is the method that, sorry about that, guys. I don't know why that happens occasionally. Zoom just randomly signs me out. Anyway, okay, we're done with that. You guys can still hear me okay and stuff, right?
Yes, sir.
Cool, cool. Okay, so now you can see that we have, it prints out uploading C# memory and delegates, and then it says a video has been uploaded. This seems like a fairly sensible approach to doing this, right? We've now just created the diagram that I showed you on the slide. I'll go back to it now. I'm just neatening up things a little bit. So it's a lot of code, probably the most you guys have seen in a while. But we basically just created this simple structure. So you go ahead, you create new content, you upload it, and then it just goes ahead and notifies the subscriber class. Okay. So that's how we would do it. And what I want to just clarify is why you wouldn't do it this way practically. And again, it relates to how you work as a programmer in a large company, okay? Or on a large application, rather, like on a large project. You can see that in the uploaded method, we are creating the subscriber object, but the main thing is that let me give you a simple example. Let's say we're unhappy with the name of this method. It's currently called notify subs. Okay, we're unhappy with the name of this method. If we want to rename it, like let's say I just want to rename it to notify subscribers. Subscribers. So simple change, but you can imagine it could be more complicated in like an actual company, right? In like an actual Google, you could be making a more complicated change than that, right? Rather than just renaming it. For example, let's say you also want to be able to notify for bell notifications. So you add another method for bell notifications, right? So for people who have clicked the bell, like bell clicks or something. Okay, bell notifications are a good example. Let's say we were adding that kind of functionality. In order to notify those people, I would actually have to go to the video uploader class and edit the uploaded method. Now you can picture if you're a developer at one of these businesses and they say, oh, you must add a thing that allows you to notify people who have clicked the bell. You might go, okay, it makes sense. I'm going to have to edit the subscriber class a little bit. But does it make sense for you to also have to edit the video uploader class, right? And you can imagine there's lots of classes, right? There's all of these different classes. How are you supposed to know exactly where you need to find the code that you want to edit? It would be easier if everything you had to edit was in one place and you could just like, and it still worked. Like you could just sign up and say, okay, this must happen. Whenever a video is uploaded, this must happen. You don't actually have to edit the uploaded method. Instead, the uploaded method will talk to you, right? Like the uploaded method would say, oh, by the way, I just uploaded something. And you could just say, all right, that means I must do this, right? Rather than having to edit the uploaded method itself. And that's what events allow us to do. So that's why our approach to this is wrong, because we had to edit things in the uploaded method. Okay. Events and delegates allow us to solve this problem. So before we stop, I don't know if we're going to have time because there's only 15 minutes. I mean, maybe we can. So that's why our way is wrong. Yeah. So we could, AB, if we were editing the front end, we could create that kind of thing. For now, we're just working on analogy though, right? Like you can imagine that they typed the name into a field and then we gave that to the constructor instead. You can imagine that happening. But yeah, that's true. That's true. The user would be able to type their own title, exactly. Okay. What we're gonna do is use events and delegates instead to be able to handle this problem in a neater, more sensible way. So we're going to reset the example a little bit. So we've got our various participants in the system. Okay. What we are going to do is we are going to make notify subscribers listen for something. Okay. We're going to say, all right, your job is to notify subscribers. You must just listen until something happens. So just wait, okay? Just listen, just listen. And obviously we have to tell it what it's listening for, okay? How we do that is we define something called a delegate. The delegate defines basically the format of a method, okay? The format of a method. So it says, the delegate goes, look, this is about to happen. It has a certain shape. You can see the delegate has the certain shape. And the delegate is going, look, this is about what's about to happen. If you guys know what a delegate is in the real world, it's like a messenger, a communicator between two parties. So delegates inside C# are the same thing. They're, in practice, what they are is a reference. You remember we learned about references earlier in the lecture. A delegate is a reference to a method in practice. But you can see it as just defining the format of a certain thing that is going to occur. Okay? The format. So it has this certain shape. Okay? So it's like an agreement. Notify subscribers expects to get something that looks like this delegate. Okay? So now instead of just, so you could see in the previous example, when we uploaded a video, we directly called notify subscribers. Instead, what will happen now is when the creator uploads some content, we're just going to shout. Okay? We are going to shout in a way that is similar to the delegate. Okay? You can see the same shape, right? The same shape. Our shape has the same shape as the delegate. We're just going to shout. And when notify subscribers hears that shout, it knows the format of the shout. Before the shout happens, it knows what it'll look like because of the delegate. The shout happens, and we know how to shout because of the delegate. Like we know what shape all of our subscribers expect because of the delegate. So the delegate is like defining a contract between the thing that is listening and which we call a subscriber. By the way, we call it a subscriber. Okay. The thing that is listening, the delegate is defining a contract between that and the event. So us shouting is the event. Like I uploaded a thing, an event has occurred. Okay. We're announcing that this event has occurred. Okay. When notify subscribers hears that that event has occurred, it goes ahead and notifies the subscribers. Okay. So you can see what we've done is using this delegate, we have disconnected the two parties. Okay. Looks a little bit abstract, but when you see it in code, it might make a little bit more sense. And actually, yeah, I think, so 12 minutes is going to be cutting it fine. We might spend a little bit more time on it next week. But in principle, you'll see that this is actually not so bad. There's a couple of steps. We need to add an event to the video uploader. So when a video is uploaded, video uploader is going to shout and say, I uploaded a thing. And anyone who wants to listen for that shout can. Okay. All right. How we do this? We have to, let me actually point out where this is in your book as well. Okay, focus on the slide. I do remember the book's example is pretty bad anyway. So yeah, we will just focus here. Cool. Okay, there are 4 steps to doing this. Okay. We have to create the delegate. Okay, create the delegate. Okay. We have to then create the event. So we have to say, so we're creating the delegate to define the contract. Okay. We then create the event. Okay. We then start listening. So that's like adding the ear. Okay. So we can say subscribe to the event, but that's like adding the ear. So like listening for the event to occur. And we then say, we then raise the event. We actually shout, okay? Raise the event, so we shout. All right. It looks difficult, but it's not too bad, okay?
So can you please copy paste the code in the chat?
Oh yeah, sure. You know what, I can do better than that, actually. What I'll do is I'm gonna hit save here, and I'm gonna say events and delegates. This is not Bryanston High though. Let me change there we go. I'm gonna hit save. And now you can open an exact copy of what I've got here. If you go to that
Thank
URL, you'll be able to get an exact copy of it. Yeah. Cool.
Thank you, sir.
So we're going to start by creating the event. It's fairly simple, okay? It's just a method, basically. It's going to look something like this. Public delegate, that's a keyword, void, uploaded. What we usually call events is handlers, okay? I mean, delegates, we usually include handler in the name, something like that. Uploaded handler, okay? So this is the handler for the uploaded event. You could also call it the messenger or the contract, something like that. Any visualization that helps you work with it. I know the standard is handler, so I am going to introduce you to that one. But I mean, the fact that they call it a delegate and then in the name they say handler, it's a little bit weird that there's all of these different metaphors and analogies. But yeah, I do want to introduce you guys to the standard way of doing it. But yeah, cool. So that's that. We've created a delegate. Okay. Created a delegate. Ooh, what am I? Ah, right. Ah, wait, no, okay. We'll use the delegates and then we'll see what happens there. Okay. Cool. That's the first step. We then want to create an event, and it's also pretty easy to do. Okay, public events, uploaded handler, uploaded. I'll be impressed if I manage to get through all of this without any any errors, because there is quite a lot. Let me just make sure that we, oh, what am I missing here? Oh, cannot specify. Oh, let me just see. Am I in the right place here? I am. Okay, let's continue and we'll see where, and we'll solve the little syntax errors later. Okay, cool. Oh, and by the way, guys, this is on, I found the page, it's on page 40. They, for some reason, decided to cover delegates and events at the beginning of your textbook. I'm not sure why, but yeah, that's what they did. Yeah, okay, cool. Subscriber does not contain a definition for notify subs and no accessible. Oh, subscriber does not. Oh, right. Sorry about that. I forgot that we renamed it to notify subscribers. Okay, cool. There we go. Now everything will be okay after we start referencing things, I think. Yeah. Okay, cool. Don't worry, because there's still some things that we have to change because uploaded is gone now. Okay. Cool. So we've created the uploaded events. Okay, so we created a delegate. That's like the contract. Okay. We then created an event. So the event, you see the event specifies the uploaded handler, right? The event specifies the uploaded handler. Why is it doing that? Because that's telling the event how it must shout. Okay. When the event occurs, this is how it must shout, the format of its shout. That's what the delegate is defining. And you can see that the delegate is void and it takes in no arguments. Okay. What that means is that anyone listening to this event must be void and take in no arguments. So you see, notify subs is going to be listening for the uploaded event to occur. And I'll show you how we do that later. But what's important is that, let's say notify subscribers returned a string. That would mean the delegate would say, oh, by the way, all of your subscribers return a string. Okay. Because notify subs is void, the uploaded handler is void. And the same goes, let's say we were giving the notify subs the title. So like we said, string title. Okay. If that occurred, the delegate would have to define that. Okay. Which means notify subs would have to take in a title. So this is literally defining the contract. What the delegate is doing is defining the format of the event, right? Like the format for the methods that will subscribe to the event, okay? So when the event shouts, it knows exactly how to shout, and what the methods that subscribe to the event look like know exactly what they're supposed to look like. Okay. It'll make more sense once you see the example come together at the end. The next thing is usually when programming, and in all languages, so this is true in JavaScript, in CSS, in any language with events, usually the event or the thing that raises the event has on in front of the name. Okay, so you say like on click, right? When you click on a button, an event called on click is usually called. Okay, and the same is true here. When a video is uploaded, the method we call when a video is uploaded is going to be called on uploaded. Okay, so like on click, on uploaded, that kind of thing. Okay. The next thing we have to do is subscribe to the event. And this is the important part because this is what they like asking theoretical questions about. Okay. We now need to subscribe to the event. Instead, what we need to do is we need to tell notify subs, we need to create this ear here, okay? We need to tell notify subs to listen for when the uploaded event occurs. And it's quite easy to do actually. So we've created the delegate, that's defining the contract. We've created the event, that's telling video uploader how to shout when the uploaded event occurs. We now need to make sure that notify subs has that little ear, okay? Has that little ear, and it listens for the uploaded event. How we do that? I am going to create subscriber sub equals new subscriber. And I'm going to say that this subscriber, so sub.notify subs, needs to subscribe to the uploaded event. How we do this is quite simple. We literally just add it to the event. So you see uploader, inside our uploader object, there is the uploaded event. So we can say uploader.uploaded plus equals sub.notify subs. And that's it. That's it. So you see the name of the event is uploaded. We want sub.notify subs to subscribe to that event. That's how you do it. Okay. Notice I'm not calling the method. This is why we learned references earlier. Sub.notify subs is a reference to the notify subs method. It's not calling the method, it's a reference to the method. So when the uploaded event occurs, sub.notify subs will hear that it has occurred and it will be called. Okay? And the reason why uploaded and notify subs know what to look like is because of the delegate called uploaded handler. Okay. What's important here, guys, what you'll be asked questions about is this plus equals. You must know that is how you add to the uploaded event. If you said equals, then any previous things that subscribe to the event, right? So let's say we had another subscriber. I'll do it that way. So I'm going to create sub 1 and sub 2. Okay. And both of them need to subscribe to the uploaded event. Okay, so sub 1.notify subs plus equals. Okay, and sub 2.notify subs, we'll say plus equals. Okay. If we didn't put the plus equals, then you wouldn't be adding things to the invocation list. You wouldn't be adding things to the list of methods that must be called when the uploaded event occurs. If you just say equals, you're not adding, you're overwriting. So the entire list would just be sub 1.notify subs. And when I get to the next line, the entire list is just sub 2.notify subs. So we say plus equals because we want to add these things to the list. We don't want to overwrite the list. Okay, so that's an important thing to get. And there's the last step is just to shout, okay? So what have we done currently? We've created a delegate that defines the format for the shout, okay? We've created the listener, so notify subscribers is listening for when the shout occurs. The last thing is to actually shout, okay? And that's called raising the event. So in the onUploaded method, I am going to call the uploaded events, uploaded. And when I run this, you can see a video has been uploaded. So it notified all the subscribers. Okay. I know it's quite a lot to take in, and it is sort of interesting how this flows. But remember, if you understand this diagram, you understand what's going on in this code, okay? We have a delegate defining the contract between the subscribers and the event. We define the event itself so that when it occurs, the event knows how to shout. We subscribe by adding methods to the list of methods that is called when the event occurs. And then we actually call the event. So in order to subscribe, right? In order to subscribe now is very easy. Like if I have another subscriber and they also want to be notified when a video is uploaded, it's as simple as just adding their notify subs to the invocation list. Just say sub 2.notify subs. And when I run this, you can see that a video has been uploaded is called twice now. Okay. If I had another subscriber, I don't have to edit the video uploaded method. Notice how easy it is for me to add more subscribers. Okay. And now it'll be called 3 times. Okay. So that's the power of events, guys. All right, I know chapter two is tough, but I hope my explanation made it easier a little bit, or easier than it would be to learn from the textbook. But yeah, thank you guys for coming. That's it for today, and almost to chapter 3. Stick through it, guys. Chapter 2 is tough. It's tough. I know.
Thank you so much, sir. Have a good day.
Yeah, you
Thanks,
too.
sir. God bless you.
Yeah, thank you too. You too, Chico.
Cheers.
Cheers, guys. Thank you all for coming. And yeah, I'll upload the video to YouTube as usual, and see you next time.
Cheers.
You too, Chris. Bye-bye, bye-bye.